Imagine I handed you a $100 bill right now. You'd trust it's worth $100 because you can see it, feel it, and the government backs its value. But what if I told you people around the world are exchanging billions of dollars in digital money with no government, no banks, and no central authority at all? In 2008, someone using the name Satoshi Nakamoto solved a problem that stumped computer scientists for decades, creating digital money that can't be copied, forged, or double-spent. This solution wasn't just clever code. It fundamentally changed how we think about trust in the digital world. Today, we're breaking down exactly how blockchain technology works, why it matters beyond just cryptocurrency, and why some believe it's the biggest innovation since the internet itself. The internet revolutionized information sharing. I can send you a photo, a song, or a document instantly. But here's the problem. When I send you a digital file, I'm actually sending a copy. I still have the original. This works great for sharing cat videos, but it's a disaster for money. If I could send you $100 and still keep that same $100 for myself, what economists call the double spend problem, digital money would be worthless. Before Bitcoin, the only solution was to have trusted third parties, banks, PayPal, Visa, maintain the official record of who has what money. These institutions verify transactions, maintain the ledger, and we pay them fees for this service. Blockchain technology created something revolutionary, a system where we can transfer value directly from person to person without needing these middlemen. A truly peer-to-peer electronic cash system. At its core, a blockchain is exactly what it sounds like, a chain of blocks. But instead of physical blocks, we're talking about digital blocks of information, linked together using cryptography. Think of a blockchain as a special kind of database or ledger. Traditional databases are centralized, controlled by one organization that can add, delete, or modify records. But blockchain databases are distributed. Copies exist on thousands of computers worldwide. Immutable. Once data is added, it cannot be changed or deleted. Transparent. Anyone can view all transactions. Secure. Protected by advanced cryptography. Let's use the Bitcoin blockchain as our example. When I send Bitcoin to someone, that transaction gets broadcast to a network of computers called nodes. These nodes collect new transactions into a block. Think of it like a page in a ledger. Before a block can be added to the chain, the computers compete to solve a complex mathematical puzzle, a process called mining. The first computer to solve the puzzle gets to add the new block to the chain and receives newly created Bitcoin as a reward. This process happens approximately every 10 minutes. Once a block is added to the chain, it's linked to the previous block using a hash, a unique digital fingerprint created through cryptography. Each block contains the hash of the block before it, creating an unbreakable chain all the way back to the very first block, called the Genesis block, created in 2009. In traditional systems, we trust banks and governments to maintain accurate records. Blockchain replaces this centralized trust with distributed trust using some clever computer science. The first innovation is decentralization. The Bitcoin blockchain doesn't exist on one server. It exists simultaneously on thousands of computers worldwide. For someone to hack or alter the blockchain, they would need to control 51% of the entire network's computing power, which is practically impossible for large networks like Bitcoin. The second innovation is the consensus mechanism. For Bitcoin, this is called proof of work. Miners compete to validate transactions by solving complex puzzles that require enormous computing power. This ensures only legitimate transactions get recorded because the energy cost to mine makes fraud economically irrational. Let me give you a real-world example of why this matters. In 2013, the government of Cyprus announced it would seize up to 10% of citizens' bank deposits to address the country's financial crisis. Many Cypriots lost their savings overnight. But if those funds had been in Bitcoin, no government could have seized them because there's no central authority controlling the network. Let's walk through exactly what happens when I send Bitcoin to someone. First, I need a wallet. Not a physical wallet, but a piece of software that stores my private and public keys. The public key is like my account number that I can share with others. The private key is like my password, which I must keep secret. When I want to send Bitcoin to you, I create a transaction message, send 1 Bitcoin from my public address to your public address. I sign this message with my private key, which proves I'm the rightful owner of that Bitcoin. This transaction gets broadcast to the Bitcoin network, where it sits in a waiting area called the mempool until miners pick it up. Miners gather multiple transactions into a block and compete to solve the mathematical puzzle. The winning miner adds the block to the blockchain and broadcasts this update to the entire network. Other nodes verify this new block is valid and add it to their copy of the blockchain. Once my transaction is included in a block and that block is added to the chain, it becomes permanent and irreversible. Your wallet now shows the additional Bitcoin. What's fascinating is that this entire system works without requiring us to know or trust each other. I don't need to know your real name or trust that you're a good person. The cryptography and consensus mechanisms built into the blockchain ensure the transaction is valid and permanent. The ancient Hawala system in the Middle East and South Asia operated on similar principles of trust, without centralized authority. For centuries, people transferred value across vast distances through a network of money brokers, working on honor and reputation. Blockchain brings this concept into the digital age, with mathematical certainty replacing human trust. While Bitcoin was the first and most famous application of blockchain technology, the innovation extends far beyond digital currency. Ethereum, the second largest blockchain network, introduced smart contracts, self-executing agreements with the terms written directly into code. These enable complex applications beyond simple money transfers. We're already seeing blockchain used for supply chain management. Walmart uses blockchain to track food from farm to store, reducing the time to trace the origin of produce from 7 days to 2.3 seconds. During the 2018 E. coli outbreak in romaine lettuce, this technology could have prevented nationwide recalls by precisely identifying the contaminated sources. Voting systems. Countries like Estonia are experimenting with blockchain voting to create tamper-proof election records. Property records. In countries like Georgia and Sweden, governments are moving land titles to blockchain systems, reducing fraud and corruption that has plagued paper-based systems for centuries. Digital identity, blockchain, could give people control over their identity information rather than having it scattered across countless databases. Healthcare. Medical records on blockchain could give patients control over their data while ensuring doctors have accurate, up-to-date information. The technology is still evolving, but many experts believe we're just scratching the surface of blockchain's potential. Just as the early internet in the 1990s gave little indication of today's connected world of smartphones and streaming services, current blockchain applications may be primitive compared to what's coming. Blockchain technology represents a fundamental shift in how we establish trust in the digital world. For the first time in human history, we can transfer value and record information in a way that's transparent, immutable, and doesn't require trusted intermediaries. Whether blockchain fulfills its revolutionary potential remains to be seen. Critics point to energy consumption concerns, scalability challenges, and regulatory uncertainties. Supporters believe these are early-stage growing pains of a technology that will transform finance, governance, and digital ownership. What's undeniable is that the core innovation, creating digital scarcity and trustless consensus, has already changed how millions of people think about money and trust in the digital age. Until next time, this is the Wealth Squad, and don't forget to get money by income. If you're serious about building wealth in today's economy, understanding these financial innovations is essential. Smash that like button, subscribe to our channel for more strategies to grow and protect your money, and drop a comment sharing your own wealth building journey.